Hello learners, welcome to Unit 5 in the course Introduction to Abstract Algebra. In this minute, we'll be looking at very important concept in mathematics, that is complex numbers. In the previous unit, we looked at number systems where we considered real numbers, rational numbers. If you remember, we did continual fraction, that is finite and infinite. In this session, you will learn more about complex numbers, what they are. We also learn the properties about complex numbers. We go ahead to find the end fruit of complex numbers by the end of this unit. So in this section 1 of this unit 1, complex numbers, we are looking at the definition of complex numbers. I am Munkaila, that's my name, your course instructor for this course. By the end of this session, you should be able to define an imaginary number, explain what a complex number is. You should be able to find the real and imaginary parts of the solution to a quadratic equation, and also find the conjugate of any complex number. Okay, definition 1. Let's look at complex number. An imaginary number is any number of the form bi, where b is a real and then I is square root of -1. So in other instance, you can refer a complex number to as an imaginary number. So that's the definition. A complex number actually is in the form bi. The b is a real number, and then the I is given by the definition square root of -1. Okay, so with the introduction of the set of complex numbers, we can find a square root for every real number, whether positive or negative. Remember when you were in JHS, a solve question, or even in senior high, and they get square root of negative number, we say it doesn't exist. It's not true, it exists, just that it wasn't your level. In other parts of the country, they do that, or other parts of the world, not Ghana. Okay, so indeed, so let's look at some positive rules govern complex numbers. So when I have, let's say the bi, that's an imaginary number square, what does it say? It says that this is the same as b square dot I square, and I hope you agree with me completely. Yes, if that is the case, then this is the same as b square times -1, and what do I get? Minus b square, because from here where I equals to square root of -1, when I square both sides, I'll get I square equals to -1. So take this one note, very important. I square equals -1, because throughout of this course you'll be using this one. Okay, we can also see, for instance, when I have square root of, let's say, -9, how do I solve this one? So square root of -1 is the same as square root of -9 is same as -1 times 9, and I think you agree with me. Then by the multiplication rule of Z, you can get square root of -1 times square root of 9, and then square root of -1 is what? I, and then square root of 9 is 3, so you get 3i. So in complex numbers, we say the I comes after the number 3i. Likewise, square root of 100, -100, what do I get? -10i, -10i rather, 10i, because of the negative of the square root of the -1 is actually I square. Okay, so that's about the complex numbers. Great. So let's look at example 1. Find the root of the equations z squared plus 2z plus 2 equals 0. This simple quadratic equation. So if you will go by factorization approach, you can see that it's very difficult to find factors in order to make the equation factorizable. In that order, or in that instance, we can go in for other approach, either by completing the squares method or by quadratic formula. So let's go by the quadratic formula. So by quadratic formula, you can see that z will be equals to minus b plus or minus square root of b square minus 4ac all over 2a. Okay, and this will be equals to, you put the values in, minus 2 plus or minus, that is b square root of b square, and then which is b is now 2, so b square gets 4 minus 4ac, so get 4 minus 4ac gets minus 8, all divided by 2a, which is 2. And what do I get? So you get minus 2 plus or minus, don't forget about the square root of 4 minus square root of minus 4. What do I get? Square root of minus 4. Okay, let me write down there. Minus 4 all divided by the next one, that is your 2. So solving this one, what do you get? You get actually minus 1 plus 2i, or you can get minus 1 minus 2i. Okay, so that becomes the solution to this simplest or simple quadratic equation. Now note that the two solutions are neither real numbers nor they are purely imaginary. Imagine the first part is 0, like 0, something like this, 0 plus or minus, let's say ai, all divided by something here. You can see that it's purely imaginary because the real part is 0. So we'll be looking at that in other instance of this session. Okay, so that is the solution of this. Next session or next page. Definition 2. A complex number is a number z of the form z equals a plus bi. We've already talked about that, where a and b are real numbers and I is a number such that I squared equals to 1. So here the a is what we call real parts. I've talked about that already, and then b is the imaginary part of z. So we normally use real re to denote the real parts. So if I want to write the real part of z, I write real part of z, and then im to denote imaginary axis, imaginary parts. So the imaginary part of z is imz, so you can write that. So that is, here you can see that imz equals to b, and then that is a is also equals to the real part of z. So that is very interesting. The complex plane, so the complex plane is just the usual two-dimensional plane with the interpretation that a point in the plane corresponds to the complex number z equals to a plus bi, and that is it. Z equals to a plus 2 bi. So here the horizontal axis of the complex plane corresponds to the set of real numbers. You can see that the real numbers is the a, that's horizontal axis. Then the vertical axis corresponds to the set of complex numbers. So here is the complex numbers. As you can see, the horizontal axis is the complex numbers. Okay, so that is actually about the complex plane. We will be using this more, so know about the real part and then the imaginary parts, or the imaginary axis. Thank you. The complex conjugate. So let's look at the definition. The complex conjugate of z equals a plus b I. So z equals to a plus b I. So if you want to find the conjugate, then we say that the conjugate is given as, just put bar on top, and it's given as negative bi. So that is a z conjugate of z, the conjugate of z. Okay, so that's very, very interesting, and we'll be using the conjugate to do a whole lot of things. Okay, so section review. In this section, we look at an imaginary number, and we said that it's a number of the form bi, where the I is the square root of negative 1. And we also look at the conjugate, complex conjugate, where we denoted by a plus bi. We put the bar on top, so the conjugate of this z is actually equals to this. So we also look at that. So I give you the simplest assignment to go and prove the conjugate of a conjugate is actually equals to z. So the conjugate of z conjugate equals to z. So proof or how show that the conjugate of a conjugate is actually equals to that same number or the same complex number. Thank you for your time.